All right, folks, welcome to this workshop. Today, we're going to talk about how to integrate AI into your applications without necessarily being the AI expert, right? So the way we're going to do that is using Microsoft Cognitive Services APIs. So first off, let's talk a little bit about what is AI, just so we know what we're working with. As developers, it's always interesting to learn new things, and it's always interesting to look into the libraries and the packages we're using. So let's do that first. AI is basically whatever a computer can do yet. So that is an interesting description of the state of AI right now. In fact, this has been getting better almost every year. So soon enough, there will be very few things that computers cannot do. But yeah, so when you think about software engineering, what exactly are we doing, right? We are essentially telling the program, telling the computer how to execute certain things. And that is just logic that comes from us, right? But what AI is trying to do is essentially teach the computer how to learn how to make decisions so we don't have to think for the computer and we don't have to tell it what to do. You should be able to figure out what to do by itself just by looking at data. So the science and engineering of making intelligent machines, especially intelligent computer programs, and that would be a different definition of AI. By intelligence, we just mean that instead of being told what to do, it is figuring that out for itself. And when you look at the difference between humans and some like less intelligent animals, that is actually kind of the difference. This is what makes humans quote unquote intelligent. We would like to think so. And then another definition is AI is computers doing things that we would normally think of as intelligence in humans. So there is a Turing test that you may be aware of, and that is a person will be chatting with an entity. And if the person cannot tell if the entity is chatting with is a chatbot or a actual human, then that's when we know the AI has achieved a certain level of intelligence. And that's when we say it's close to singularity. So how does AI actually work, right? Everything starts with data. There's some kind of sensory input, and there's some kind of model, and that will lead to behavior. The reason we're showing a human face here is because this is also how humans work, right? Think about the visual information you're taking in from your eyes, the audio information you're taking in from your ears, right? Depending on what you hear and what you see, there's some kind of model already built in your brain. And you have learned this model, you have refined this model through interacting in the world. And that will lead to a certain set of behavior, right? So let's say, you started out as a fresh new baby, you don't have any information, and maybe one day you decided to touch the fire because it's, nice, bright, and it's like moving around and it's interesting. And unfortunately, maybe you got a little bit burnt, right? Because you experience pain by touching something that is red, maybe your model will say, oh, based on that data, we should not touch red things because that will hurt me, right? That will be painful. But maybe later on, your parents bought you a red little toy car or a red I don't know like toy oven. Maybe not oven. That's a bad example. Maybe like a toy doll, right? Or toy teddy bear. That's right. And you decided to play around with that toy, and you're like, okay, yeah. So I see that this is red as well, but it did not hurt. Therefore, maybe I was wrong, maybe not everything that's red is going to be bad for me, right? So notice how based on data, you just updated your model and that led to a different set of behaviors, right? Maybe, who knows, later on, maybe like red is your favorite color. So that's a behavior change. So let's think of this and convert it into a bot, right? Quote unquote bot. This could be a bot in the case of chatbots, or it could be a bot in the case of robots, but it's basically the same thing. You have data coming in, and it has a model that's trying to learn from, right? The model is just telling it what to do when certain types of data comes in. And based on the model, it will have an answer, right? If the answer is incorrect, the model will be penalized, kind of like the way humans experience pain. And the model will know, okay, what I did wasn't that great. What else should I try? What is a better thing to do? And that's essentially how machine learning works, or how AI works. This is very similar to how you would learn as a human. So far, nothing really complicated. If you understand how humans learn, you can understand how machine learning works, and you can understand AI at this level. So then let's go through an example of classification, right? So you have some red dots and blue dots, and maybe these represent samples of the test that are actually COVID positive or actually COVID negative, right? And let's say you were able to design an algorithm that looks at that data set and then splits them into two groups. So what you see here is that there is a blob on the left that is mostly blue, and there's a blob on the right that is mostly red, right? So you're like, yes, that is true, but I see a red dot in the group of blue dots, and I see a blue dot in the group of red dots, right? So what is going on there? This is an example of showing you that AI is not infallible. In fact, AI frequently makes mistakes, right? The severity of these mistakes depends on your use case and your downstream impact. So in the case of medical settings or sometimes financial settings, these mistakes are very costly. But in other cases, not really a big deal, right? You know, if you build a classifier to say if there's a hot dog in a photo or not, it doesn't really matter if we get it wrong once in a while, right? So all of this, you know, all of the advancements that we see in our everyday lives, much of it is actually enabled by machine learning. Just think about the examples that you have, right? When you call Uber, you're actually being computed by algorithm to figure out which car is the most suitable for you, which car is the nearest by, which car will be close to you after it's dropped off its last passenger, right? That is an AI algorithm. If you go to Netflix, right, there is suggestions for you based on what you've seen before and maybe things that you will potentially like. That's new. That's also AI. Other cases of AI, including robots that are building with artificial intelligence that actually helps children learn how to read and interacts with children, etc. So it's actually getting quite advanced, and we'll expect to see more and more AI integration into our everyday lives. Even if you're not an AI developer or if you don't even care about it, it is still happening. So let's demystify this idea of machine learning a little bit more, right? By looking at actual data. Previously, we're just talking about pictures and you're like, yeah, that's easy. But what does it actually look like when you have data? So let's look at this table we have here, right? You're like, okay, cool. This looks like just any kind of normal Excel spreadsheet, nothing's fancy, and you'll be right. There actually isn't anything special about this. But what you do see is that the first 4 rows are what we call training data, and then the last row is essentially our test data, the thing we're trying to predict. Typically, what happens when you're doing machine learning is that you would build a model, you would train it on the training data where you already know the answer. So you can tell the machine to try to figure out patterns, right? Just like, if you touch a red fire, it hurts. And then if you touch a red, fire truck, it doesn't hurt and you're having fun. So you're essentially trying to learn from the patterns given the data that you have. But then let's say like a red chili pepper shows up and you've never seen this before, right? Now you have to make a decision if this is something that you should be engaging with, or if this is something that potentially will hurt or is dangerous, right? And depending on what you picked, you will get to learn about chili peppers that are red. So over here, one potential use case is that if we're trying to predict housing, right, which is the last column that we're seeing here, these are things that we call label under things to predict, right? This is the thing that we're interested in. So in the example that we kind of were talking about just now, it could be like, hey, given the object, is this going to be a fun object or is this going to be a crappy object, right? Is this a dangerous object or is this a I don't know, like a toy or some kind of entertainment device? So then we also have information that we know, right? Even for the data point that we don't have, the chili pepper, we also still have information that we know so that we can try to predict whether it's dangerous or not. In our case, we know the color, right? That it is red. But in this case, we actually have more data. So each row is essentially one human individual, and we know certain things about each individual. For example, their age, their income, their education level, and their gender, right? And our goal is to look at the patterns of how age affects whether this person owns or rents or other. I'm actually not quite sure what that means. And how does income affect their housing status? How does education affect their housing status? How does their gender affect their housing status, etc. So the question is, what is the difference between machine learning and AI, right? So our artificial intelligence could be packaged user experience. I think it's more flushed out as a product. And typically, you have pre-trained models that you can use. For example, you can get access to models that are already, intelligent, already trained on data in Azure Cognitive Services, and we'll go through an example of that. And the machine learning is where you have models that you build and train yourself, right? So how do you go from machine learning to AI? According to this, you train your model and you make it, available, and you actually use it. Machine learning is actually more useful for advanced or specialized scenarios, right? So for example, if I'm trying to build an algorithm that does trading, and I'm trading something very specific, for example, sunflower seeds, right? This may be a model that I have to build. I do not expect, Azure to have a model that says, here is the model that predicts sunflower seed prices, right? So then that's where you have to kind of go to machine learning. So there are plenty of AI packaged services that are available, and Azure is one of them. And the benefit of using these services is that it gives you a good 80-20 solution. What does that mean? You spend 20% of effort and you get 80% of the result, right? And in most cases, whether you're a startup or whether you're a developer trying to build an app, this is the best solution. If you're trying to build an AI-empowered app, it is kind of unreasonable to assume that every developer who wants to do that will go learn about machine learning, spend a few years building models, and then they can go try to build the thing they're interested in building. If we all did that, we would all have fun, but I think we would not see as many AI-powered products, right? Even if you're experienced machine learning person, a professional, you have a lot of experience and you have a team of data engineers and data scientists and researchers, etc. Sometimes it still makes sense to use a off-the-shelf model, to use artificial intelligence by maybe borrowing a model and directly calling it using API. And the reason is that sometimes that is just the most cost-efficient and time-efficient solution, right? If you already deploy a model that's maybe doing okay, maybe 80%, and that's not great, but okay for your use case, that just means that while you're learning from new user data and while you're trying to work on a better model, you already have something that's out there in the market, right? So that is way more beneficial than you trying to wait until you have a model that was 90% accuracy, and that may or may not ever happen, right? And maybe by the time you accomplish your goal, some other startup already went to market using a API service, right? So these are considerations for when you should be building your own and when you should be trying to think about using an off-the-shelf solution. So here are roughly some of the ways we can use AI, and these are roughly correlating to different kinds of ML algorithms, right? So we have one over here that's called which category, and this is what we call classification. Notice how these can only end up in one or two buckets, right? Anytime you have an answer that is having to do with which group is this in, is this A or B, any kind of question you can answer with a yes or no, that's typically a classification example. The reason we want to talk about what kind of problem we're trying to solve is that depending on the problem, you should be using different models and different solutions, right? For example, if I'm trying to classify image, it doesn't make sense for me to call an NLP API, right? So it's the similar things to what ML model you should be trying to use, and you should be trying to rent or borrow from some kind of ML AI platform. So the next one that we have is predict how much or how many, right? And this is regression. So sometimes people are a little bit confused about what is regression and what is classification, right? Because honestly, if I just tell you classification will give you a answer that's yes or no, or it will give you an answer that is is it a cat or a dog, like a string or a kind of a label. That's not always true, right? I could also ask you what is the month that an individual was born in which case we'll say 1 for January, 2 for February, etc. You still get a number as a result, but that is classification. So how can we tell if we're working with a regression example or a classification example? So one simple trick is imagine a possible answer that your model might give you, right? And add a very small number to that result. Does the answer still make sense? So in one of the examples, we can actually try to build an algorithm that predicts someone's weight based on their height. And typically you would expect there to be some kind of positive correlation, right? So if you're the question you're trying to answer is, if you have someone's weight, well, if you have someone's height, what is their weight? Weight could be 65 pounds. I think that's possible. I actually don't know. I'm more like I'm more based in kg. So, but let's say 65 pounds is like a reasonable answer. Maybe this is like a child or something like that, right? Then you can try to add a small number to that. Is 62.3 pounds still a viable answer? And when I think about it, I'm like, yeah, it's entirely possible for this person to weigh a little bit more, right? Maybe they ate a big lunch. Maybe they bulked up and gained a lot of muscle. So yeah, that's a possible answer. So in that case, because adding a very small value to the original answer still makes sense, then I would say that's a regression. So then let's compare this to a classification example, right? What month is the individual born in? Let's say the answer that I got back is 12, which is a valid answer. 12 stands for December, right? That's a possible month that someone could be born in. And then if I were to add a small value to that, let me add I don't know 0.4. So the answer is 12.4, right? At that point, what does 12.4 even mean, right? Is it like halfway through December, in which case it should still be 12, right? Or are you talking about like into the next year, like somewhere in January? In that case, the answer should be 1 because I asked you which month you're born in, right? So 12.4 doesn't make any sense, but 12 does, right? So in that case, that's a good indication that you're working with a classification problem. Another hint you can look at is if the answer you're trying to predict in the data set that you have over here is like if it's a number, is it a whole number or not, right? So in the case of predicting months that you're born in, 1 is a whole number, 2 is a whole number, 12 is a whole number, right? But if you're predicting someone's weight based on their height, you can entirely expect to see floating point numbers and decimal numbers, right? So now let's talk about some of the other AI algorithms, the other classes of AI algorithms that we have available to us. So there is a, the next one is anomaly detection. Is it weird, right? Is this abnormal? And there's actually 2 ways this could show up. It could show up in a classification example, and it could show up in a regression example, right? So let's say usually I have a assembly line, and then the sensor on the machine is typically registering room temperature, right? That's good news. Nothing's on fire, nothing's too cold to be moving smoothly. But one day the sensor registers something like 80 degrees Celsius or 80 degrees Fahrenheit if you wish. I'm sure that's still like pretty high temperature. Then you would say, hey, something is weird. This is strange, right? Usually the temperature is not like that. The other example would be predicting in a set of transactions, like credit card transactions, if one of them is fraudulent, right? The reason that sounds like classification, but actually is anomaly detection, is only because if you were to randomly take 1,000 transactions, right? Just randomly sample 1,000 transactions from some kind of credit card company, you will only expect a few of them to be fraudulent, right? And because the natural occurrence rate of fraudulent transactions is so small, this is why it is weird, and this is why that's an anomaly detection problem. So then what's next? We have reinforcement learning. This is actually something that's super exciting, right? Reinforcement learning is a kind of algorithm that typically does not require having labeled data. What does labeled data mean? So notice in the previous example here in this table, we had way more data, aka 4 rows, where we know what the answer is already, right? We know for the individual age 61, they own their housing, they own their own home or where they're currently living. And for the individual that's 22-year-old, maybe just like a student, right? Recently graduated student or something like that, they're renting, right? So we have a lot of data. And based on this data, we can try to figure out the patterns. And based on the pattern, we can try to figure out, is this 31-year-old likely renting or owning or something else, right? But for reinforcement learning, we typically do not need to have the answers already, right? Reinforcement learning is an algorithm that is most similar to this case of human learning. It is learning by interacting with the environment. And therefore, there's a reward function saying, hey, how well you're doing, right? And our reinforcement learning is typically trying to maximize that reward. You see this in animal experimentation and training all the time, right? If you're trying to train a rat to do a maze, you basically give it a reward, a little treat at the end of the maze when it succeeds, right? There's no reasons, rats are going through mazes. Absolutely no reasons at all. It's probably having fun, running in a hamster wheel, right? But if you keep giving the rats a treat at the end of their maze, solving successfully, they're gonna start to really want to do the mazes. They will actually start to prefer the mazes versus the hamster wheel, right? So that's how you can essentially do some kind of reinforcement learning, right? You're reinforcing the right behaviors. So then the next one we have is kind of data structures or clustering or recommender. So what this is doing is actually also unsupervised, right? A good example of this is that, let's say you're a marketing agency or you're a startup and you have some customers, right? And the question is, what groups of customers do I have in this data? If you already knew about this, if you already have the answer, you wouldn't need to be asking this question, right? But maybe you don't know. So what you can do is, take all your user data, hopefully you got permission to, register that data. Hopefully you told the user what you're going to do with that data. So nothing is like without their permission. And you then take that data that you collected and you got permission to use and you put into a clustering algorithm, right? What that algorithm will do is say, hey, it looks like there's actually 3 groups of people in your data set, right? And these are what's common about them, right? In this example, it's actually a little bit hard to tell. I don't really know what is the commonality between these groups. And this is actually a good example of how ML could be useful when humans are actually not able to do a good job, right? Maybe there's a really good reason that these people are grouped into 3 clusters, except I have no idea. I don't know how the ML is doing that, selection. So with that said, let's talk about the cheat sheet, right? Given that we have different classes of algorithms, you can actually figure out what is the problem you're trying to solve, figure out what kind of problem this is, and then look at the box that corresponds to the question you're trying to answer. And then you can choose one of these algorithms to try and build a model off of, right? All of these are expected to be available in Azure Cognitive Services or Azure ML. So that is good. Do people have any questions? If there's any questions, feel free to put in the Q&A and we'll answer them as we see them. Yeah. Okay. Legit. So I won't go over these in detail. Once you have built enough intuition, once you have enough experience, you can kind of quickly tell, oh yeah, this is a regression problem, but I think maybe neural network regression will work better and decision tree regression will work better, right? And maybe it's a simple problem, and then you can say, oh yeah, I think I should use linear regression because this will be fast, and I don't actually need it to be that accurate, right? So you will learn how to make these trade-offs as you get more experience, and this is part of like becoming better as a ML engineer or ML researcher. So let's look at where AI is being used today, right? Here they're using a chatbot to do better question answering to provide quotes, right? How is this useful? I sometimes really hate it when I have to wait on the line to talk to a human, right? Sometimes the question is super simple and maybe a bot could give me the answer and that's all I need to do. I don't want to bother a human. And this is clearly also saving Progressive, this insurance company, quite a lot of money, right? And sometimes it's actually not a bad idea for the bot to take the first step because if it's a simple question that actually doesn't require humans, right? The bot will just provide the answer and then the human can work on the things that it really cares about, right? The things that the humans will find more interesting. So if I was an insurance agent and you asked me, oh, where can I find the list of prices where what insurance you have available? I would say, oh, that's a great question. Here's the URL. But if people keep asking me that, I will start to get bored and I will be frustrated with my job, right? But if these questions are handled by the bots and I only get to questions that the bots could not handle correctly, right? Maybe the question is, hey, I'm a single mother. This is the car that I have. I'm worried about, like damages to my house because I live in a disaster zone, or I'm worried about, this car having these kind of problems, but I'm trying to save money. What kind of insurance should I get is more suitable for me? Then I'm more interested in answering these kind of questions because it's more difficult. It's using my creativity, and I feel like I'm actually helping another human being, right? So then let's talk about Uber. Uber uses cognitive services to help the driver using the app matches the one on the file, right? So this is a safety thing. Sometimes you will get into Uber vehicle and you're not really sure if like the driver is the right person. It's entirely possible that the driver, that's driving you stole the car and then now like something bad is going to happen, right? So this is another way we can use AI to improve safety for writers. So Microsoft is trying to make AI available to everyone, and they're doing that by making these APIs available, making these models available using API in their cognitive services, so that they can solve the most important problem of the society and their economy without having to, go through a PhD process and spend like 3 years in the industry trying to learn how to do AI, because that is highly inefficient, right? We would much rather have teachers focusing on teaching, our next generation. We would rather much rather have medical doctors working on research than having them learn AI and then be able to do their medical research a little bit better, right? So obviously AI could be used for good purposes and bad purposes. And in the end, it's just the technology. It is up to us to make sure it is being used for good things and it's causing the results that we want. So this is an example of using AI to save wildlife, and that is a good example of like using AI for good. So here's how they're actually using that, right? If you're in some kind of safari or nature reservation or preservation, right? You're trying to understand like what is the number of animals of each species that you have, and this is a way that you can use computer vision to automatically tag and label the different animals, right? So instead of having to sit there or drive around and count how many zebras you're seeing, etc., how many giraffes you're seeing, and maybe it's the same one, but then you just counted it twice, you can actually set up these, computer vision cameras that will, count how many zebras it's seeing in that location. And this just makes conservation efforts much easier, having accurate data, right? Maybe giraffes are actually not that endangered, and therefore you should maybe allocate the money that we're spending on giraffes because we saw they were endangered for some reason towards actually more endangered species, right? Okay, yeah. So image analysis, we're actually getting so advanced at AI, specifically in the use case of like nature conservation, to be able to identify unique individuals, right? So remember how I said that there's a good chance that like you won't be able to tell two leopards apart, or two elephants apart, or two giraffes apart, right? But AI is able to do that because just like fingerprints are unique, the patterns on animals are also unique, right? And sometimes the patterns on animals are not unique. For example, an elephant, it may have like, just patterns of like skin creases and wrinkles, depending on how it's been moving around and what its ages. But it's able to identify markers like, old cuts that have healed and et cetera, right? And even in the case of a whale, right? This is a whale that's kind of coming up for air and is disappearing very quickly. You can actually compare if these are the same whale by looking at the patterns of their tail fin, right? So with one like second of data, like one image, one snapshot, you can do that comparison in real time, and that is like quite nice. I don't think I have that ability without, years of practice and training. So we will talk about demos in a little bit. We're just gonna kind of like cover the last bit of the slides, right? So today what we're going to do is essentially try to build a travel app, right? We're going to try to learn how to use the APIs so we can build a travel app that makes someone's travel experience better, right? And in the process, we'll learn how to use the computer vision API, the translation API, and the sentiment API. Today, we're not going to use facial recognition because, as you may be aware, there's a lot of misuse of facial recognition technology. And at this point, it's potentially leading to more harm than good, right? So because we're really not sure how facial recognition is being used and we don't want it to be misused, we're not going to focus on it today. But the documentation is there if you're interested, and feel free to look around, right? So at this point, it is important that we set up our Azure Cognitive Services account. So you can actually start a free trial, and if you were to do that, this will be free. I'm not sure if it required a credit card for the sign up, but you can also just cancel it, and you don't need to be worried about getting charged. So once you have this set up, then what we can do is look at some of the APIs that are available, right? For example, today we'll be covering computer vision pretty in a lot of depths. We'll focus on this. So you can maybe click on the computer vision API. And from here are some examples of computer vision, right? if you were to passing a image and you can passing a URL, the results you can get back will be essentially these rectangles of where the objects are. And this is also the same example we saw with the animal conservation case, right? It tells you not only that there are humans or giraffes in the photo, it also tells you exactly in the photo where they are, right? The other thing is it will tell you like what object did it identify and what is its confidence about, hey, I'm pretty sure this is a train. In this case, it's pretty confident, even though the train is actually moving pretty fast, right? So there's also description. What could this be used for? Well, you can actually use this to automatically tag images, right? So I don't know how many times I'm trying to show my friend like a really cool photo, maybe like from Burning Man or something like that. But then I'm like scrolling, scrolling. I would like it would be really cool if there is some kind of API that would tell me and tag the images. So when I search Burning Man, it just automatically pops up without me having to say, oh, this image was from Burning Man, or like scrolling, for like 2 minutes, etc. So let's give this a shot, right? What if we passing another image? What if we passing this image? I think you can actually choose the image to try yourself, so let's do that. Let us go to Google and see if we can find some kind of like photo. Anyone have ideas of what we can try? Maybe like tacos? Let's go to images. Let's find one with a nice photo. This one looks pretty nice. So I think what I want to do is actually this. Oh yeah, nice. So let's try this. Does it know we're looking at tacos? Oh, it's saying, yeah, we have food. That's pretty good. They also figured out this is fast food. Oh well. Oh, it's actually figured out this is Korean tacos. Okay, yeah, with a little bit less confidence, you see? So it's pretty sure that we have fast food. It's also pretty sure that we have food. It's actually rather interesting that it's more confident about this is fast food than the fact that this is food, because fast food should be like a subcategory of food, right? But this is the example of like AI not being quite there yet, because this doesn't make any logical sense. And then it's also pretty sure that this is baked goods, which I wouldn't consider like tacos baked goods, unless you have like a taco cookie or something like that. It's also seeing salad, because I guess there's like cilantro, etc. But yeah, this is a fun exercise, and you can go ahead and try that. So what I'll do is I'll post this URL into the Q&A for you, so you can play around. So with all that said, we are actually going to try to do this ourselves. Okay. So let me restart the service. What do I want to do? So for this class, I have prepared a notebook with example code that we can walk through. What do I want? I want reactor. Just bear with me 1 second. I'm just trying to find the link for you. Maybe Microsoft Reactor. So this will be a good time for everyone to try to set up their Azure accounts, because we will need to use this. And as always, if you have any questions, feel free to ask. So I'm going to go to my fork, because that's where the code is. I'm going to go to a slightly different branch. And here is the notebook we'll be using today. So let's look at this code real quick, right? We have some imports. We're installing some packages we'll end up using for the purpose of like visualization. And over here is where you would need to sign up for an account, because you need to get your primary key and your URL endpoints here, right? So once you have a account set up, what you can do is actually just go to my account and go to the portal. And here are all the cognitive services that you can set up. So what you can do is create a resource group. And then here you can say, computer vision. and you can click create, right? This process is actually fairly intuitive, but after you go through this, I'm not going to do it again because I already have one. What you will end up having is a set of keys that you can use, keys and endpoints. So I'm not going to show you my keys, but this is what you would copy and put into your notebook right here. And you would also, if you want to run the code with me and also do the translation part of this, you would also need a translate key because you need to provision a Microsoft Cognitive Services translation endpoint, and you will also need the sentiment key, right? But basically, the process is the same. You create a resource and go here. You search, translate. You click create. It will take you to a dashboard-like thing where you can actually click into this. And if you go to your keys and endpoints, that's how you get your key, right? The other thing I want to point out to you real quick is that the location actually matters. And you will see where we're using this when we're doing the API calls. So what I'll do now is I'll send this URL to you. What you can do is just download it or run it just like a Jupyter notebook. The other thing you could do is actually use Binder. By the way, this will also work in VS Code. My environment is just not set up right now, so this is why I'm using Binder. So what I can do is go to my repo. So I'm gonna give you the link to Binder in case you want to run the code along and you don't have a Python environment set up. So what you do is you paste in this URL to the top box. And you need to go to a specific branch. As you can see right here. And from that, this was working just moments before, but this is a experimental service, so let's see how it goes. So what's happening is that this is on the back end, making a clone of my repo from that branch and setting up a container. And the benefit of using this is that, assuming it works, you don't need to do environment setup, and you have your own container to run code. It is not persistent, as in you will not be able to save the code that you ran. If you change the code, it will not be there the next time you do this. But this is a good tool for like quick experimentation and quick learning. So we're just waiting for this to get ramped up. Yep, so I see a question asking if we can have more time to set up. 100%, right? So I'm just going through the process, similar to how you would have to go through this process. And we will essentially wait until everyone that wants to run the code with me has had a chance to do so. And if you have questions about like where to get things, or if you need additional instructions, or if you're just interested about asking about AI and data science and machine learning, how you can use it to build, cool AI-empowered products, some of the things you need to watch out for, etc. How can you use, translation, natural language processing, computer vision? Those are all good questions that I can answer right now because people are doing setup. All right. Okay, so if you were watching my screen, what happened was the Binder container showed me a URL. And at this point, if you have, worked with Jupyter Notebook before, this will start to look very familiar to you, right? But the code I'm actually interested in is here. I'm just trying to run this one Jupyter Notebook. So what I'm going to do is I'm going to get my key set up. And at that point, it will be a good time for me to wait until people are more or less ready. So we're going to give people like 5 minutes to get set up here. And then I'll get started with the content because I'm sure everyone's trying to run code and play around with the code. And if after 5 minutes you're still not done, you still want more time, just put a message in the Q&A and we'll wait. So I'm gonna stop sharing my screen for a quick second so I can get my key set up. The reason I'm not, showing you my keys is that it's actually a security concern. It's a good practices to never show your key, anywhere on the internet. So after I get the keys copied in, I will proceed, right? But just to show you what this might look like, let's look at the API here. Let's go back to the portal here. If you click on this, you go to keys and endpoint, and here is where you can copy the key and paste it in right here. So I'm gonna not share my screen for a second, and I'll be right back. So I am back after setting up my keys, and I actually just removed them. I ran the cell, and then now the keys are loaded into memory. So I actually just wiped out that cell, right? But someone was asking me how to go over the setup process again. So the first thing you need to do is sign up for a, Microsoft Azure account. And unfortunately, I can't show you the exact details because as you can see, I'm already logged in, I already have an account, so it would not be possible for me to sign up for an account again. But once you go through the sign up process, you should end up on this page right after you log in. And after you log in, you can click on portal. And at this point, you will probably not see all these endpoints, right? So what you can do is click on create a resource. And what you can do is look for the resource that you want. And today there's actually two that we'll definitely go over, and that is computer vision. Oops. So click on this and click create. I'm not going to go through this process again just because I already have a endpoint created. I'm not sure if it's going to clash or not, so that's why I'm not showing you the exact details. But when I did all of these, the process was actually pretty simple. In the end, what will happen is it will show you a way to get your keys. So what you can always do is, go to your login page again. So if you're not sure how to get access to the dashboard after your services has been configured, right? I know that UI sometimes is a little bit confusing. Just look for Azure Logging again. And this is the URL you should use to essentially see all the services you have configured. So once you're here, you should see at least one of the services you just created. So for example, if you create a computer vision version, you can click into this. It's taking a hot minute here. I'm actually not sure why it's so slow, but okay, yep, it's responding. And once you're here, there's actually a quick start guide, right? So if you want, you can look at the Python version. That's actually the one we're mostly focused on today. But you can use this API in any of these languages. As long as you can make an API call, this will probably work for you. So this is also like good documentation. I'll send that over as well. But the whole point is, once you click into a cognitive services you just created, for example, this is the computer vision one that I created for myself. You can then go to keys and endpoints. You are going to need this endpoint for sure. I'll show you where to set it up in a bit. And you're going to need to copy one of the keys. So your computer vision key will be the first key. So if you look at the version I have here, this is your computer vision key. This is your translate key after you create the translate cognitive services endpoint. And this is the sentiment key. Depending on how we're doing with time, we may or may not talk about this because I want to give people a chance to run the code. And yeah, and it's less important we cover like additional APIs because once you know how to use one API, it all works like pretty much the same way. So I am going to proceed, and I'm proceeding because I don't know how everyone's doing. If you're like almost done and you just need a couple more minutes and you want me to wait further, just put a message in the Q&A and I will wait for a little bit longer. In the meanwhile, feel free to ask questions. So this is where I actually put in my keys, and because I'm trying to not show my keys on screen, I actually just deleted all the code. But because I already ran it, you see this number 4 here. So if I run this again, run the next cell again, you see how this is 6. If I do that again, this will be 7. So I executed the cell in the fourth as the fourth step that I did in this notebook. So what that means is my key is actually loaded into the Jupyter notebook memory. So even though you don't see it here, it actually knows what that value is. For example, it knows what this key value is, and therefore the rest of this will work just fine. So don't be confused that it's like, Maddie, where are the keys? You told me they're important. Okay, so I'm gonna proceed. I did not see any request for additional time. So once you have the keys loaded, the next thing we need to do is set the endpoint, right? So as you can see here, we're going to be calling an endpoint, and that is typically a URL. Everything else is more or less set up except for this. So we need to define what is the base URL. So the base URL is actually something that you can also get from your cognitive services. And the base URL is the one for computer vision. And that is right here. So I'm just going to copy this and put that over here. And this needs to be a string. So let me run this. And if you experience the error, it's like, hey, I don't know what the API key is for base detection. That is okay. Just comment this chunk out because we will not be covering that today. Feel free to explore that by yourself if you're interested. This will now execute correctly. So the next thing we're going to do is use a function that sets up the API call, right? Because we're going to be making repeated API calls to different endpoints with different data and different headers. We just made a generic processing function that does some error handling, does some of the requests. This is just a helper function. You don't need to worry too much about it. So feel free to look at the code a little bit later, but you can just run the cell and this will be fine. And in the next cell, this is just a helper function to make the results that come back from the API look a little bit nicer. So this is also a cell that you can just run, and there should be no errors, no problems. And by the way, you will notice that I ran this first cell here, right? So this is how you can install packages in Jupyter Notebook and not do it in the terminal. So I'm just saying that I need to import, I need to install OpenCV Python, I need to import matplotlib, and so I need to install it in the environment, and I need to use some of these nice packages to make the result look nice. And you will notice here that there's a function to restart the kernel, because after you install this, your kernel needs to get essentially restarted just so all the changes are taking effect. And here are some of the packages that we're importing, right? If you're not interested in knowing the details, you can just run this out, no problem. But we're using a package that we can use to make API requests in Python. CV is actually OpenCV, which is a common image processing or computer vision library. CV stands for computer vision. And some of the other essentially helper tools. So I'm kind of just stalling for time, hoping people have a chance to catch up. But anyways, let's look at this, right? So what we're doing here is that let me actually run the code first and walk through what exactly happened here. Okay, so we sent an image, which is this. You can trust me that this is the image of a Colosseum, but let's just verify, Yeah, it is the Colosseum. Great. So I actually agree with the answer that came back, right? What we're asking for here is that I actually want to know the results in terms of the landmarks, because we're using a travel example. It would be very nice if you can, go through all my photos and tag all the landmarks, so I can say, oh, show me that photo that I took at the Colosseum, and I can use it easily to show my friend, right? So you'll also notice that what you're getting back is confidence. This is how sure it is that this is the Colosseum. One thing you do need to be aware of is that if you're using deep learning models, frequently it is overconfident, right? Frequently it's more sure than it should be. And this is different if you're using kind of a Bayesian model, a more probabilistic model, where the confidence are more based on statistics and more to be trusted, right? But either way, we're very glad that it identified the correct answer, and also it's very confident about its correct answer. If it had said this is I don't know, what's a good landmark? Maybe the Statue of Liberty, and it was very confident, you'd be like, oh no, this algorithm is not doing that great. So speaking of Colosseum, this is the function that we wrote to essentially render the image and also label and put the result on top of the image, right? So this is essentially now a automated image labeling service. So then let's try a different endpoint, and this is all the different ways you can have fun with these APIs. So let's go to Google again. Let's find an image of a landmark that we can potentially use. This is not what I want. Nope. Okay, will be a good one. Let's see. Pyramid. I'm pretty sure I spelled that wrong, but that's okay. All right, so this one looks like pretty nice. Let's see if we can get a URL that we can use. So the trick is that you right-click on the image. It will give you a drop-down, and you can try to open the image in a new tab. And this is a good URL to use because it ends in image format. Sometimes this is not the case, and your algorithm won't be able to figure it out because it's not actually getting image. What it's actually doing now is going to that URL, which is the image. It's actually converting that into binary data. Well, not binary data, but essentially like pixel data in number formats. And then it's calling the API and analyzing the image, right? So what would we expect the result to be? Hopefully, the pyramid. Oh, I actually didn't identify anything, and that's why this is having trouble. So maybe let's try a different image. How about the Statue of Liberty? The thing we're just talking about. Maybe this one. So what I'm thinking about right now is that I want to find an example where I would expect the algorithm to have an easier time recognizing the landmark, right? So you don't want something that's like super small because it might be getting confused. And also this is not a good angle. Like it's not the most obvious angle of like this iconic landmark. But you also don't want something that's like too stylistic. So let's give this one a try, right? So see if we can open this image in a new tab. Did this ending JPEG? This did. All right, let's give this a shot. Once again, AI is not magic, so. Huh, we also don't get any results. Interesting. Let's try something else. Let's try golden. So I think this one looks pretty good. Okay, yeah, let's give this a shot. So one of the reasons that it's not able to recognize the previous image is that, you know, the pixel and the image density might be too small. So let's see how we do with this one. Oh, look, we got a result back. That's good. I was almost a little bit worried for a sec. So yeah, we were able to get an API call result. So let's do the next section, and that is essentially labeling images, right? So there's actually a nice example image on the Microsoft Computer Vision API documentation page, and it looks like this. So our goal now is trying to essentially do the object localization step, right? What does object localization mean? You're essentially trying to find where the objects are in the image, but then you also need to identify what these images are. Sorry, what the objects are, right? So what do we see here? I see a phone, I see some coffee, or maybe tea, I don't know, some kind of beverage. I see a kind of like a portable computing device. There's a toaster and a pot in the background, so this is probably a kitchen. I see a counter. So what happens if we try to make our API label this? Okay, so I think I'm hitting an API limit. Let me actually change that real quick. Let's change this to 90. Okay, try this again. Okay, so for some reason it's not letting me make this API call. I'm not sure if this is a persistent problem or something else. So I am going to show you what the result will look like. So you would expect to see something like this. And if we look at potentially the code here, actually there's no code here, so we won't get to see that, but that's okay. So this is kind of like what the result will look like, right? It will identify where the items are and also what they are. This is exactly the example we were just looking at before, right? So if we look at the links that we were putting in the channel or putting into the Q&A, this is exactly basically this. So I'm not sure if you're having any luck with running that API multiple times, but hopefully you're not experiencing any errors. So yeah. So the next thing we can do is text recognition, right? If you have a image, can we make a label? The text. And the answer is yes. So notice how I give it an image, but it's able to essentially render that, identify where the text is, and also figure out what the text is saying, right? So I'm actually pretty like pleasantly surprised that it's able to identify this DEPT of transportation, the small text right here at the very bottom, right? So notice that it made a mistake. On the top one it was correctly able to identify it was DEPT, as in Department of Transportation, right? But on the lower side, maybe there's like a speck of dirt there, or maybe the angle is incorrect. It actually made a mistake. It said third of transportation, right? Once again, AI is not perfect. AI is allowed to make mistakes. So it is then our job as developers trying to use AI to think about what happens if there's a mistake in the algorithm, right? How do I prevent users from like acting on wrong information? So once again, the result that will come back from the API that currently doesn't work, which is this one, will look very similar to what you see here, because we're essentially calling the same API, right? We're saying, look, show me where the the boundaries, the corners of the rectangle is where you saw the word DEPT. All right, so we're able to, we're able to like grab text from the signs, right? Maybe I'm taking a photo and maybe there's a sign saying, hey, welcome to, I don't know, welcome to Canada, right? If I'm looking for photos that have to do with Canada and this image was tagged using this API, then I should be able to find it, right? So this is how we're using these APIs to improve travel experience. And I don't know about you, but when I travel, I do take a couple photos. So then let's talk about translation, right? Obviously, translation is one of those things that like is very nice because it helps you communicate with the locals, right? It helps you like have a more immersive experience. So we are going to run the code here, and we're going to try to make it translate a sign. But the first thing we need to do is identify what text in the sign, right? So this is similar to what we did before. So we're actually going to make it translate this image later on, but right now we're just trying to get the string out of this image. And this is what we call essentially a text recognition problem, or OCR problem. So notice how the results came back in bits at a time, right? This is actually a pretty hard problem to solve because I don't know if you know much about images, but every tiny little red dot here is actually a pixel. So this algorithm needs to go through all the pixels and figure out, oh, here I see a white one right next to a red one, and that's something that is interesting. I should, note that, right? After it's done the scanning one time through all the pixels, then it's gonna try to use the pattern it's learned based on previous signs that have strings in them, have text in them, and try to convert that into the actual text, right? And so far, I would say it's doing a pretty good job. I even realized that the word open is capitalized, so that's awesome. So then what about translation, right? We also have code for that. So today we're going to translate it into German, which is DE. So I think there is a small mistake in my code. It's actually not a mistake. It's actually probably because I did not set the region correctly. Remember how I was saying that you need to watch out for the region for the translate API? I basically made the mistake that I told you not to make. But it's easily fixable. So if I go to my translate endpoint and I go to keys endpoint, I can actually copy the location and replace that. So instead of US East, I'm going to say Australia East, and I'm going to run this. By the way, I think this is the option you can select when you set up your endpoint, your cognitive services. So you can choose the US one if you're in the US. So we do this again, now it's working. What do we get back? We have detected language. Notice how I didn't say that, hey, our sign is in English, right? It figured out, oh yeah, we're looking at English sign, and the score is 1. This is essentially the confidence score, like how sure it is that this is actually English, right? It was pretty sure. And then the next one is the actual translation. Because we asked the algorithm to translate from English to DE, which is Deutsche, which is like essentially German. This is the text that comes back. So I wonder what happens if we put this into Google Translate, because honestly, I'm not a German speaker. So when you're doing machine learning and AI, it's very helpful to be slightly paranoid, because making a small mistake and catching yourself early is going to save you a lot of headaches down the road, right? So I'm not gonna select the language. I'm hoping this will figure it out. But hey, it actually did figure it out. It figured out this is essentially like German, detected German, and it's able to figure out that this is ComWare Open. So we went from ComWare Open into translated using Microsoft Azure Cognitive Services into I don't know how to pronounce this. You can try clicking this, but I'm not going to do that. And we went all the way back into English again. So great, this did a good job. Going back to where we were before, this is actually just processing the data and pulling out the thing we're actually interested in, which is this, right? They're just doing essentially plumbing and processing. So after we have that, we can now relabel this image again. Imagine, having an app where you can take a photo of a sign, and let's say you're a German tourist in Canada or in the United States. Now you can know exactly what the sign says. So that is pretty useful. I think a really good use case of this is actually like translating menus. Sometimes I go travel to like a place, and I'm really interested in their food, and I'm looking at their menu in a like completely different language, and I'm just like, I have no idea what I'm looking at. Do they even have vegetarian food? I don't know, right? Yeah. So this is actually like all the official APIs we wanted to cover today. But while we're here and while we have time, unless anyone has any questions, etc., we can actually also talk about sentiment analysis, right? So what does this mean? Given some text, we want to basically have a score saying, is this text positive or negative? Is this happy or not really, right? So hate speech would be negative, and if it's like a compliment or just like normal language, it's probably positive. So we can also run this API. So notice how easy it is to set up many APIs once you have done the process once, right? With this one function that we wrote that does the API calls, we were able to essentially set up a bunch of libraries we're going to use to make our API calls appropriately. And most of this is actually just like, plumbing and metadata, right? For example, what visual features do you want to get back? And where is your endpoint located, stuff like that. This doesn't actually require any like, too much engineering per se. You're just copying pasting things. But once that's set up, and once you have a function that does the API call right here, you're essentially able to play around with all the different results, right? Once you know how to make one API call, all the rest of the API calls you will find to be very similar. So now we're asking for a string, right? I don't know. I might say tacos are nice. So I got a positive score. So what if I translate something else? I actually don't know what this means. But yeah, it's able to essentially do sentiment analysis in Spanish. I don't know what this person said to me, but they were positive, and this algorithm is 75% confident it was positive. So let's try this again. What about this sucks? Oh, okay, so basically you figured out this is really negative. What if I am so happy that my, I don't know, cup died? Oh, so we figured out this is actually like negative. Probably because the word died has a very, very negative connotation, but I would actually say this is probably supposed to be positive because I said I'm happy, right? You don't know why I'm happy my cup died. Yeah. So after all these API calls, we're like, this is great. We're still just running Python code, right? How do we actually use this? Here is where I can show you a fully integrated app. So if you go to that URL that I sent you, actually here you should go to the actual Reactor URL. So let's go to GitHub. Microsoft Reactor. So yeah, I hope people were able to run the code with me, and I hope you're not, experiencing the errors that I'm experiencing. But I think that's just the rate limit on my APIs, because I set up a free account and I use the least expensive option or the free option. So maybe it's like, hey, you're making too many API calls, because we spend a lot of time trying to find an image of the landmark that actually works, right? So you may not experience the same thing. So what I want to do is send you to this. No, I clicked on the wrong thing here. So this is actually an example of an app building Flask. And using this app, we're actually able to do some of the things that we just did, but now it's a full product, right? So let's go to this app. So let me actually start the server again. Give me 1 second. I need to start the Flask server. Okay, yeah, so here's our little, travel app, right? And here are all the things that we already did, right? But I'm just going to show you one example, and that is translating a sign with a URL, right? So I did exactly the same thing. I give it a URL that I'm essentially trying to translate, and I said, load URL. Oh, it figured out that this is spam. Great. So what if I want this to be some other language? Maybe Italian. I don't know what spam is in Italian, so let's try that. Huh. It somehow still figured out it was spam. Maybe it's just the same word. But yeah. So this is an example how you can essentially integrate these API calls into your real app, right? For example, if you wanted to build a travel app for a travel startup, you can essentially allow translation of images from a URL or from a local upload on your phone. You can essentially try to find landmarks. If you're like, oh, that looks like an interesting building, interesting church, I don't know what it is, right? Maybe you're interested in learning about the history of that building. Then you can try to find a landmark with an upload image. You can also do object detection, etc. And you can also do sentiment, right? So let's say someone's trying to say something to you, and you're like, first of all, I don't know what that means, so I'm gonna translate it. And two, I would like to know if this is a positive message or negative message. So you can use the sentiment API, right? So this is just a very, very crude example of a website that you can build and a real product you can build with a few simple API calls. So at this point, this is the end of our content and our workshop. So what I would encourage you to do is play around with the code here, right? Try different things, try to understand, when it's able to correctly identify a landmark, when it's unable to do that. And if you play around, you will start to see patterns, right? What I noticed is that if you give it a very small image that has low pixel density, it will have a harder time figuring out what it's looking at. And this is the same thing for humans, right? Like if you give me an image that only has 4 pixels, I would honestly not know what I'm looking at. So same thing for computer vision API, right? Another example is that if you use images that have a lot of sand or a lot of background that is noisy. So for example, if you showed it an image where there is only a little bit of I don't know, a little bit of the Colosseum, but with a lot of images of people, then you may also get confused again. So the Pyramid of Giza example is also difficult because there's actually 2 landmarks in that image, right? One is the I think is the Sphinx, is essentially the lion statue, and there's also the pyramid in the background, right? So these are all examples of where this API is likely to fail. And you can also, test the capabilities and the accuracy of how well you can expect the API to do to pull string out of your images. So an interesting experiment we can run here is that is it able to see neon signs and recognize that correctly, right? So let's go to Google again, and let's go to images. Let's try neon signs night. So what I'm curious about is that if you have a dark background and bright text, which is actually counter to most of the cases you will see. In most cases, you have a light background and dark text. I wonder how well it's going to do in this case, right? So we're essentially being ML scientists, and we're playing around and we're doing experimentation. So let's give this a shot, see what happens. And maybe it will error out, I don't know. It's doing okay. Let's see how well we did. Oh, we did pretty good. It figured out good nights. So yeah, it's actually doing pretty well. Yeah, so this is all I want to say. Thank you for joining me for this workshop. If you have any questions or if you have any questions or if you have errors that you want to resolve, feel free to put it in the Q&A. And if not, we can end the workshop a little bit early and you can have 30 minutes of your day back. But yeah, I'll hang around for the next 5 minutes or so to answer questions.
Thanks, Maddie. So for everyone who's still here, we just wanted to share that we have a survey link, and if you have any feedback at all about how the event went today, we'd love to hear what you have to say. So there's a link, I just posted it in the chat as well with the code 7841. The code helps us know that you're definitely giving feedback on today's event. We'll put some slides up as well if you'd like to see. But thank you so much for joining us. Please stay tuned on our meetup pages for any upcoming events. We have events all across the world in different time zones, so you can join our meetup pages for that time zone. My colleague is just going to put some slides up with some links that you can go to. We have a ton of events across many different verticals and different types of technology. So if you're interested in today's AI's events, you like data science or machine learning, and things you want to learn, we definitely have a ton of content coming up. So thank you so much for joining us. And if you have any feedback, I think we're all still in the chat room for a bit, so you can definitely type your comments in here. And we will share out, apologies, and we'll share out a link to the YouTube recording for today's event as well. So if you want to follow along at home, you can go to Reactor YouTube channel, and we'll put the link in the chat as well. And you can rewatch that and follow along at home. Thank you.
So I'll hang out for essentially 3 more minutes. This is an opportunity for you to ask any questions about the content we just went through, or overall questions about AI and data science and machine learning in the real life. And if there are no more questions in the next 3 minutes, then we can close the workshop early, so you can have time on your own to experiment with this code. One thing I do want to point out is that if you are a little bit familiar with Python and Flask, you can actually go to the repo I sent you here. And if you go up one folder, there's actually a starter site, right? So what this is that this is just a template with a bunch of things that are not filled in. So if you wanted to actually practice how to integrate an API call into a real web app, right? This is how you would do it. So we left comments and prompts. Actually, I realize I'm not sharing my screen, so let me do that real quick. So the URL that you got earlier is actually for the solution site, right? So this has all those things filled out. So if you look at this file over here, the API we're calling was translate, and here's some code, right? So if you wanted to try to integrate, some of the API calls that you just learned into a real web app, which basically allows you to build like any kind of AI-empowered application as a developer. You may need to learn a little bit about Flask, a little bit about Python, but here's where you can fill that in. Basically replace the comments here with the API calls. And this should basically get you to the point where you can actually upload an image and get the translations out of it, right? So I highly encourage you trying this exercise for yourself. And if you get stuck, you could always just refer to the solution folder. Once again, machine learning, just like software development, like AI, is not a spectator sport, it is a participation sport. And you earn experience and you get more familiarity by actually practicing, right? So no matter how many books you read and how many videos you watch and how many like workshops you join, there's nothing that's going to compare to actually trying to do this yourself. So I see there's a question about how do we see the use of AI in developing countries, right? Like I said, this is actually an incredible time to leverage AI to help developing countries, right? AI as a technology is incredibly powerful. It is both powerful in the negative sense and is also powerful in the positive sense, right? Previously, in this class we covered, facial recognition API, and in fact, the code is still here if you wanted to go through it by yourself. But the reason we decided not to do that is that, a lot of these big tech companies that are powerful in AI, like Microsoft, like the other tech companies that you can think of, are reevaluating how they want to allow their technologies to be used, right? So there were some cases where facial recognition was being used incorrectly because the people using it, the developers, did not understand its boundaries and limitations. And also, it could be directly used for a bad cause, right? So in some of the protest situation going on in the States, there were cases where people were getting their images taken from cameras, and they were actually able to cross check these images on their social media data, etc. And they were able to identify who were the who were participating in protests, right? So I don't know about you, but like that's not something I wanted the government to be able to do, right? At least not for me. So one, it's a good a good excuse to wear a mask, and you should be wearing a mask for all kinds of reasons. But one of the side benefits that we did not expect is that this makes it harder for AI to recognize you and tag you and figure out who you are and maybe like cause you some damage, right? So that would be an example of like AI being used incorrectly. But how is AI used correctly, right? So there's a medical condition that is like very difficult to like identify, difficult to diagnose without the right machines, right? So what happened was because the developing country cares about children who get sick with this disease and they are disabled for life, they actually send equipment to essentially for doctors in Africa to do this diagnosis using I think it was an MRI machine or something like that. Super expensive, but we funded it, we sent it over there, and was being put into use, right? Later on, what we found out is actually not only is there a equipment shortage, which can be solved with money, there's actually a skill shortage, right? For this diagnosis to work well, you have to essentially hold the probe at exactly the right angle at the right depths. Because you press a little bit too deep, you're actually visualizing something deeper in your body, and that doesn't help. Maybe like instead of looking at your liver, you're now looking at the spine. And if you're not pressing hard enough, it actually doesn't like register the image, right? So what they ended up doing is building an AI algorithm that gives the human feedback on, oh, you should press a little bit harder, maybe move a little bit to the left, maybe a little bit to the right. And I think this was actually for like early childhood heart disease, right? And because the heart is moving all the time, what this algorithm does is that the moment it's able to recognize a clear image from which the doctors can make a good diagnosis, it just keeps that snapshot. So what ended up happening is not only does developing countries get access to these machines, they can actually just take a random stranger off the street, and because this AI is guiding the stranger in essentially using the machine, it's able to provide much more diagnoses and prevent essentially like suffering the quality of life for like children in developing nations, right? So that's another example of how AI can be used to really benefit people, right? It is in the end up to us as developers to decide how we want the algorithm to use and impact the world. And we have all the power over that, right? And here's some advice for how you should think about these problems so you don't end up like causing harm by using AI. First of all, try to be paranoid, right? Try to really understand what AI is doing. You don't need to know all the details, but at least understand when it's good and when it's not good, and have a plan for when this fails, right? Ask yourself, what happens if this algorithm is wrong? And then the next thing you should think about is actually bringing all the stakeholders to the table early, right? This is where, having diversity in the tech field and in machine learning and AI, which right now isn't very good, is very important. Because if you have, a diverse representation of people working on AI or people working on AI-enabled apps, we all know the problems that our communities are able to experience a little bit better than, like, for example, I wouldn't know what life is really like for, I don't know, someone in Africa, because I don't have that experience, but they would know, right? And they would not know what life is like for someone who's a, AI engineer in Canada, but I know what that is like because I have that experience, right? So we're all naturally attuned to the problems that affect us. So if you only have one group of people in machine learning doing the work, they're even despite their best intentions, even if they try, they're less likely to identify the potential impacts, either positive or negative, for other groups of people, right? So it's important to bring diverse stakeholders to the table early and ask them, hey, if I had this AI service, right, how would it impact you? Is this a good thing for you? Is it a bad thing for you? What would you be concerned about, right? Doing that early will, one, help you build a better product. Two, will help you essentially figure out what data you need to feed into your model. And even as a ML person, it helps you with essentially feature engineering. And three, it really helps you prevent bad outcomes that you did not expect, right? So there was another question about if we can use C# for coding instead of Python. So this is a good question. I think there is a C API. So let's look at that, right? So computer vision. Let's look at this. So for the web development part, if you're trying to build a product on the web, you probably do need either, Python or JavaScript. I'm sure there are like C-based frameworks. And what I'm looking for is actually documentation. So let's look at this real quick. Yep, documentation quick start. That's a good one. So let's look at the tutorial. Let's look at this real quick. So it looks like, yeah, there is this option. So using this, you will be essentially using the SDK instead, right? So you can actually download the SDK here, install it, and you can use it like accordingly. This will be only slightly different than calling APIs, but you can entirely use this. And in the end, if you have a package in C, I think C# that uses API calls, then API calls are pretty much agnostic, and you can also just make API calls from whatever language you're using, right? But I think predominantly people use Python because this is the default language for data science machine learning, and people also use JavaScript a lot because a lot of people try to build web apps with AI. So hopefully that answers your question. And in terms of the REST API, this actually really doesn't matter because the API is API. As long as you get the right data to the API in the right shape, it doesn't really care what language you're using. So someone's asking a question about how to connect with me post-event. I think the best way is actually just on GitHub. And this is me. So I do a lot of I do a lot of like these workshops for the blockchain field and for the AI field. I think these are two fields where it's very important to get more developers into because these are very powerful, high leverage technologies, right? And so I have a bunch of like notebooks and like code examples here. You feel free to take a look and poke around. And yeah, I hope you have fun. Are there any more questions? These are all really good questions. So I'll stay for another 2 minutes. If there are no more questions, then we can shut this down. And I will stop sharing my screen.
Thank you again for joining us. If you are not part of the Reactor community already, please do consider either joining on our meetup or directly through our Microsoft page. You also can follow us on Twitter or check out previously recorded workshops, webinars, and such through our YouTube. It looks like we have a question about how to get into AI. Maddie, I don't know if you want to answer, step
Yeah.
back in.
I'll take a stab at this. So, some people would say that, oh, you need a PhD to do AI, or you need to like be an awesome engineer to do AI. That is not true. It is true in the sense that, you know, having a STEM academic background and having gone through like advanced education is helpful, for sure, 100%, right? But it is not a requirement. As you can see, if you're able to read documentation and willing to try things, you're able to use AI as a developer, right? If you wanted to learn more about AI, there are plenty of resources, including additional Reactor events and additional tutorials online that will take you like a little bit more in detail, either in the mathematical direction or in the engineering direction, right? So I am also someone that doesn't have a like the exact researching engineering or like mathematics background. I do not have a PhD. In fact, I don't plan on getting one. And actually, all of the engineering and programming things I kind of had to teach myself, right? So it is entirely doable. So here's actually what I would recommend as a sequence of things to learn to essentially have a smooth path to essentially machine learning, right? So this notebook has timed out. That's okay. I hope it will still let me type. Yes, it does, right? So first of all, there are many different roles in AI. You can be an AI engineer, you can be an AI researcher, you can be a data scientist, you can be a analyst, right? So figure out exactly what is the thing that most interests you, most gets you excited, and go for that, right? Right now, like maybe you don't know all those things. Maybe you're like, oh, I want to be a data analyst, but later on you discover, oh, I actually want to do ML research, right? You're allowed to change your mind, but just follow your interest, follow your passion, because that's going to give you the activation energy to play around, experiment, make mistakes. Sometimes you will, have APIs not work, and if you haven't seen this before, it will be very frustrating because you're like, why doesn't this work, right? So this is where passion will like carry you a long way, and your interest will carry you a long way. So the other thing I would recommend is also like think about a problem you're trying to solve, right? The way that most people learn AI, unless you are going through the academic route, is by building projects. So think about a problem you're trying to solve, think about what kind of data set you can use to potentially solve that problem, and then just try to solve this problem by using APIs or using packages, right? So here's a list of packages that I think are frequently useful for beginners, and this is the order that people typically learn them to essentially become more advanced and more knowledgeable about AI. So first, you probably want to learn, Python. Again, nothing against JavaScript or C or anything like that, but this is just kind of one of the default languages used in AI and data science. And after you learn that, what you can learn is this package called Sklearn. So this is actually just a ML library that has really good built-in default models, and also their documentation is extremely good. So just by trying to use Sklearn and reading their documentation about the different algorithms, you will teach yourself a lot about AI. And as long as you keep trying different things, you will start to learn, oh, for this kind of problem, these models tend to work better, right? So at this point, you're probably like pretty like well into your machine learning, career or experience. The other things that you'll probably learn after Python, and this is the things you probably want to learn if you're trying to do data science. And by the way, if you haven't realized, like machine learning is all based on data, right? If you get garbage data, even if you feed it into the best model, the best API, the most powerful compute machines, you will still get a bad outcome. So it's important to learn the data science tools. That would be essentially pandas and potentially NumPy, right? So you learn these two, you essentially become a data analyst or data scientist, depending on like who you're talking to. I hope I spelled that right, but you know what I'm talking about. And then if you study Sklearn, you essentially become ML enabled, right? This is where you can build your own models and help build your own intuition to understand like how to use ML to solve problems. So after you learn ML in Sklearn, this is actually typically classical machine learning algorithms. These are not deep learning algorithms, right? I think most of the models we're using today, for computer vision, for translation, are actually using deep learning. So for deep learning, here's the beginner package you should learn, which is called Keras. So this is essentially like a higher level language that doesn't require as much details, as much knowledge to be able to build a deep learning neural networks, right? For most cases, this is where it's good enough, right? Of course, if you don't want to learn machine learning like in so much detail, you can focus on just using APIs, and then you can focus on data engineering. And data engineering, there's a list of different frameworks that people typically like to use and will have like job postings for. So look at where people are hiring and try to learn the skills, right? And then if you proceed with Keras and you're discovering that, hey, I'm having fun with deep learning, it's working out really well, but it doesn't have the level of customization and the detail that I want. Like I'm now so advanced that I want something custom and I want to like be able to tweak the model in even more detail or even more like improve the accuracy, right? In those cases, you may need to learn another deep learning framework. For example, the common ones would be TensorFlow, or PyTorch, right? So at this point, we went from data science, data analyst, to machine learning, to deep learning, to essentially a little bit more advanced deep learning. So this is if you just want to focus on the AI part of things, right? But AI is only useful if you can deploy and make it available to the world. And at that point, you need to be learning data engineering. So data engineering is like a different field from AI exactly, but this is also super useful and also a very like rewarding and interesting career path. But the things you need to learn will be different. I'm not like an engineering. I'm not a data engineer per se. I'm an ML engineer, so I can't tell you too much about this. But yeah. So you may be wondering what is the difference between a ML researcher and an ML engineer. It depends on like what your focus on is, right? I code and I also do research, which means I need to work on the math, work on the models, but then I also need to code that up so I can run the experiments and so I can deploy these models. So this is where engineering and research kind of like blend together. If you're a good coder, it will definitely help you be a better researcher. And if you're a better researcher, you basically spend a little bit less time coding and trying things. So that's also helpful. So hopefully that answers your question. So I will stop sharing my screen again. Yeah, One Code is a pretty nice organization. They also have a data science track, so feel free to look at their content as well. Anyway, so I think we're like pretty much at the end of the workshop. Thank you so much for staying with us and asking really good questions. If you enjoyed this workshop, please provide feedback. That will help Microsoft essentially offer more of these workshops. If you want more advanced content, please mention that as well. And I hope to see you later for a different class.
Thank you all again for joining us. At this time, we will be concluding this presentation.